So in part C, we're told the students plot y as a function of 1 over h squared. And we're given this graph. In part 1, we need to draw the line of best fit for the data. So what we really just have to do here is look at the points and see that they follow some sort of linear relationship, for which we can draw a line something like this. And then what we need to do is use the line of best fit to determine an experimental value for the permittivity. So what we need to notice is that from the previous equation, which was y is equal to q over 4 pi ks multiplied with 1 over h squared plus mg over ks. We see that this is on the form y is equal to mx plus c. So this here is in fact the slope, as 1 over h squared is our x-axis, this is our y-axis. So that's our slope. So what we need to do is just rearrange for the slope. So slope is equal to, like this, 4 pi e0 ks. And so we need to determine a value for the slope. We can say that we have to pick 2 points. So perhaps one of them will be 0.15, where the 1 over h squared is approximately 20. And from this we subtract another point on our line, let's say 0.12 and 0. So let's draw it something like this. And this will be 0.0015. And then we just rearrange for epsilon. So we just have to plug in everything basically. It will be q times q over 4 pi times k times the slope. And if we plug everything in, we get 8.5 times 10 to the minus 12. And then Coulomb squared per Newton meter squared. Then we need to use our best fit line to calculate an experimental value for the mass of sphere B. And well, to do this, we need to read off the y-intercept. The y-intercept in this case is 0.12 meters. And according to our model, the y-intercept is equal to mg over ks, so the mass of sphere B. And therefore, the mass is simply going to be 0.12 times 25 divided by 9.81.